Welcome to the Math Advantage podcast. I'm Dr Silas Vane, and today we're looking past the formulas to find the logic, risk, and strategy that run our world. Whether you're in the classroom or at the kitchen table, let's get started.
The hook. Imagine your school announces a new rule. Every pupil is ranked on a public leaderboard, and the top 3 get a prize. What happens next? Does everyone suddenly work harder, or does something else change? Think about Mia, age 14. She used to do steady homework and small quizzes. The leaderboard appears, and overnight she's skipping practice and chasing high-risk, high-reward tricks, copying past exam papers word for word, or gambling on single topics that students think will be on the test. The badge is shiny, but the learning that built it starts to wobble. What's the real cost here? What's the real reward?
Here's the big idea in plain English. Tournament theory, that's the technical label, is about rewards given for relative performance. Instead of saying, pass this test and you get a prize, tournaments say, be better than the others and you win. The maths behind it studies how people change behavior when rewards depend on rank, rather than meeting a clear standard. In everyday language, if the prize is for beating your classmates, people start to play the game of beating classmates, not necessarily the game of learning.
Let me tell you a short story from my time working in the city. We had a promotion system that was practically a tournament. People were ranked, and the top few earned the promotion. At first it seemed efficient. Productivity rose. But then subtle things happened. Colleagues stopped sharing knowledge, people took on flashy but risky projects, and avoided steady maintenance work that actually kept the business running. I remember one junior analyst who told me, and I quote, "I spent my time making my numbers look extraordinary, not making the model better." That line stuck with me. The variance is where the story is.
Why does this matter to you? Because small changes to rules change payoffs, and payoffs drive behavior. Think of a sports ladder. If the top 3 get medals, players may focus on beating those specific rivals rather than improving fundamentals. Or a baking contest where only the single best cake wins. Contestants will gamble on exotic flavors that might get them first place, rather than perfecting classic technique that would help them win consistently over time. That's the advantage of thinking this way. You can redesign the incentives so effort and learning are the things that win.
A short PhD polish. In operational research, we call the mechanism behind this a ranking externality. Your outcome depends on others' actions, and that creates strategic responses. The term sounds fancy, but the idea is straightforward. When your reward depends on beating other people, your best response might be to focus on what beats them, not what improves your underlying skill. Don't fear the decimal, but do watch what the rules reward.
Let's use a classroom example to make the logic concrete. 2 study strategies. Strategy A is steady study, 5 hours a week spread across topics, low risk, reliable progress. Strategy B is cram and gamble. Ignore most topics, spend 5 hours intensely on a guessed small set of topics, hoping for a big jump. Now 2 reward systems. System 1, ranked prizes. Top 3 students get rewards. System 2, absolute thresholds. Anyone who reaches 80% or higher gets the same prize. Under System 1, students who expect to be mid-pack may prefer Strategy B. It's riskier, but it gives a shot at first place. Under System 2, Strategy A often dominates because steady study reliably hits the threshold. That shift in optimal strategy is the maths of tournaments in action.
Student challenge time. Imagine you are at school and you have to choose between Strategy A, steady, and Strategy B, cram. The payoff table is simple. If you pick A and most others pick A, you get a solid grade worth 6 points. If you pick B and others pick A, you might leap to 8 points, or crash to 2 points if the guessed topics aren't on the paper. If everyone picks B, the grades compress and the top prize becomes a lottery. Here's your cliffhanger. Which strategy gives you the best chance of ending the year in the top 3 under a ranked prize system and which under the absolute threshold system? Pick a strategy now and keep listening. I'll put the answer in the show notes and we'll reveal it again at the end of the episode.
Tonight at the dinner table, you get a 2-minute win. Instead of asking, "What did you get on the test?" try this. First, praise the process. "I noticed you spent time on practice each evening. That consistency matters." Then ask curiosity-led questions. What strategy did you try for that paper, and what surprised you about the exam? Finally, avoid ranking comparisons. If your child brags about being top, steer praise to effort. "Brilliant. Tell me what you worked on to make that happen." That simple shift reinforces learning behavior, not just position.
Teacher takeaway. Here's a common misconception. Many teachers assume that public ranking always boosts effort. The trap is that rank often encourages gaming. A ready classroom task presents students with the 2 study strategies and reward rules we discussed. Ask them to calculate probabilities of success under different attendance or preparation levels. That maps directly to GCSE probability questions about conditional outcomes and expected value. For A-level statistics, set a problem where students model expected scores under ranked versus threshold rewards and identify the Nash equilibrium. That's perfect for Paper 3 style modelling and inference questions.
Differentiation tips. For lower retainers, keep the task concrete, numbers and simple expected values. If strategy A gives you a guaranteed 6 and strategy B gives 30% chance of 8 and 70% chance of 2, which is better? For high achievers, stretch them to design an incentive scheme that minimizes gaming, perhaps a hybrid, small guaranteed thresholds plus a limited number of ranked prizes, or team-based rewards that encourage knowledge sharing. Low-effort assessment tweaks teachers can try tomorrow. Anonymize rankings, run threshold-based certificates, or vary prize mechanics, so mastery, not moments, is rewarded.
A quick curriculum link. This is excellent for GCSE probability, especially questions on expected value and conditional probability, and for A-level statistics Paper 3, where students model behaviour and interpret results. Use the resource pack in the show notes. There's a worksheet with the payoff tables, a teacher answer key, and extension prompts for high achievers. Right, let's close the loop on the student challenge. If the classroom uses ranked prizes, students who are risk-preferring or who think they can beat the leaders may choose strategy B, the cram and gamble, because the upside is concentrated in the very top ranks. If the classroom uses absolute thresholds, strategy A, steady study, usually yields the best chance of getting the reward. The short answer, ranked rewards favour risky strategies and can compress learning. Threshold or mastery-based rewards favour steady, reliable improvement. I've put the full worked example in the show notes if you want the numbers.
The advantage summary in 1 sentence. Design incentives so that the path to the reward is the same as the path to learning. That's how maths becomes an advantage in life. Here's the thing. Small tweaks to rules change behaviour, and once you see the mechanics, you can design fairer, more effective systems.
Call to action. Subscribe to the Math Advantage. Download today's resource pack from the show notes. It includes the student challenge answers, the teacher worksheet, and a short FAQ on common objections. Share this episode with a teacher or parent you know who runs competitions. It might change one classroom for the better. Subscribe so you don't miss the next episode where we'll look at probability in public health decisions.
Thanks for listening to the Math Advantage podcast. You can find today's student challenge and teacher takeaways in the show notes. Until next time, keep thinking mathematically. Stay curious.